Hello students, welcome to World of Chemistry. This is Dr. Vikram Panchal and I'm discussing chemical kinetics. And in this lecture series, this is lecture number 8. In previous lectures, I was discussing about the differential rate law and how to find out order of reaction practically. In this lecture also, I'll talk the same thing about how to find out order of reaction. Okay, so order of reaction is very important part of chemical kinetics. So let us take example of N2O5, which decompose to give N2O4 plus oxygen. Now we carry experiment with this reaction of decomposition of N2O5, and in first set we took the concentration of N2O5 0.01 mole, and we found the rate of reaction was 1 into 10 raised to minus 5 mole liter inverse time inverse. Now in second set, we changed the concentration of N2O5. We took double of this, that is 0.02 mole, and we found the rate is 2 into 10 raised to minus 5 mole per liter per time. Now you can see that rate does not remain the same by if you change the concentration or moles of reactant. That means for this reaction, if you write differential rate law, where X will be the order of reaction of N2O5 and which cannot be 0 because the rate of reaction changes due to change in concentration or number of moles of N2O5. So it is confirmed that X is not equal to 0. Now what will be the value of X? That we can find out putting these values in this equation. So for set 1, rate of reaction is 1 into 10 raised to minus 5 is equal to K, and moles of N2O5 is 0.01 raised to X. For set 2, we write 2 into 10 raised to minus 5 is equal to K 0.02 raised to X. Now if we want to find out X, then we will take the ratio of 2 and 1. So if we take ratio of 2 and 1, then we will get 2 into 10 raised to minus 5 upon 1 into 10 raised to minus 5 is equal to K into 0.02 raised to X upon K into 0.02 raised to X. So here you can see that 10 raised to minus 5 will be cancelled. Kk is also cancelled. Sorry, here it is 0.01. Okay, so now we write 2 is equal to 0.02 upon 0.01 raised to X. This is equal to, here 2 is equal to 2 raised to X. If 2 is equal to 2 raised to X, that means 2 raised to 1 is equal to 2 raised to X. That means X is equal to 1. That means this reaction is of first order. So we can say that this is the reaction of first order. Okay. So this way, if in case of first order reaction, if you see these experiments, then we can say that by doubling the concentration of reactant, the rate is also become double. If you make it 3 times, then the rate will be 3 times. If you make it 4 times, the rate will be 4 times. So this way, this is the effect of changing the concentration of first order reaction. Now we will see another example in which the order of reaction will be different, because here we are taking two different reactants, hydrogen and iodine, which will give Hi. In this case, we take different concentrations of hydrogen and iodine to find out rate of reaction. Okay, and here in the set 1, let us take moles of hydrogen 0.01, moles of iodine 0.02, and here we found the rate of reaction 3 into 10 raised to minus 3 mole per liter per time. These are experimental facts, okay? In set 2, we can double the concentration of hydrogen to find out X, that is the rate of order of reaction of hydrogen, and we'll keep iodine moles same, and we found what is the change in rate, and here the change in rate is found to be 6 into 10 raised to minus 3. That means rate of reaction is not the same. That means X is not equal to 0. Now in set 3 we will keep moles of hydrogen same, but we will change the moles of iodine, that is 0.04, double, and in that case also we found the change in rate of reaction, and that shows that even y is not equal to 0. So if you write differential rate law for this reaction, then it is minus dH2 by dt is equal to K H2 raised to X and iodine raised to Y. Okay, and remember X and Y cannot be 0 due to this condition. So with reference to first set, we will put the values of all this, and we found that 3 into 10 raised to minus 3 is equal to K moles of hydrogen 0.01 raised to X, iodine moles 0.02 raised to Y. According to set 2, rate is 6 into 10 raised to minus 3 is equal to K 0.02 raised to X and 0.02 raised to Y. And for set 3, we write 6 into 10 raised to minus 3 is equal to K 0.01 raised to X and 0.04 raised to Y. Okay, now we want to find out X and Y. So to find out X, first of all, we will take ratio of second set and first set. So ratio of rate 6 into 10 raised to minus 3 upon 3 into 10 raised to minus 3 is equal to K 0.02 raised to X 0.02 raised to Y upon K 0.01 raised to X into 0.02 raised to Y. Okay, so here it is clear that 10 raised to minus 3 cancelled, K cancelled, 10 raised to 0.02 raised to Y, 0.02 raised to Y will be also cancelled. And now we got 6 by 3, that is 2, is equal to 0.02 upon 0.01 raised to X, and that is 2 raised to 1 is equal to 2 raised to X. Therefore X is equal to 1. So with respect to hydrogen, the order of reaction is first order. Now to find out Y, we have to take set 3 upon set 2. Okay, why? Because the base of X in set 3 and set 2 ways are different. That's why. Okay, that is why. So set 3 upon set 1. So set 3 is equal to, here the rate will be 6 into 10 raised to minus 3 upon 3 into 10 raised to minus 3 is equal to K 0.01 raised to X 0.04 raised to Y upon K 0.01 raised to X into 0.02 raised to Y. So this way we can see that it is easy to cancel 10 raised to minus 3, 10 raised to minus 3, K, and 0.01 raised to X, 0.01 raised to X. Okay, so now we can write 6 by 3 is equal to 2, which is equal to 0.04 raised to Y upon 0.02 raised to Y. And here this is equal to 2 raised to X. Okay, so here we can say 2 raised to 1 is equal to 2 raised to X, Y. So here we will take Y, 2 raised to Y. Therefore, we can say that Y is equal to 1. So this way we can find out y also. So y is equal to 1. So x is equal to 1, y is equal to 1. So the net order of reaction will be x plus y, and that is 1 plus 1 is equal to 2. So this is second order reaction. H2 plus I2 gives twice HI is second order reaction. Here molecularity is also 2 and order of reaction is 2. Such reactions are known as elementary reactions. So when order of reactions and molecularity are same, we consider them as elementary reaction. Now there may be one question arise in your mind that why we are taking 3 by 1? Why not 1 by 3? We will get the same answer, of course. We will get the same answer, but it might be difficult for you in terms of mathematics or calculations. Why? Because if you take 1 by 3, then it will be 3 by 6, that is 1 upon 2, and 0.02 upon 0.04 matlab 1 by 2 raised to y. So in that case the answer will be same, but if you want to calculate easily and with less time, then remember that whichever power you want to find out, for example in this case you want to find out y, then the one which is having base of y greater, it should be in numerator, and the one which is having less value of power of this y should be denominator. So it will be easy for you to calculate. That is the reason. Otherwise you can take vice versa. Okay, so that is enough in this lecture. Thank you so much.